Let's go ahead and get started here. So, hi everybody. My name is Jose Hotema. I want to welcome everyone, whether you're joining us live or watching this in the future on our YouTube channel. I'm super excited because today we're going to be discussing a very special project that we've been working here at Plus One Robotics. And in our opinion, it's going to optimize and revolutionize the way that warehouse operations are currently working on today. I am excited to be joined by my my fellow colleagues here, Joe Brandt from Plus One Robotics, and Dan Grollman, also from Plus One Robotics. To give you a little bit of a background as to who I am the solutions and applications engineer here at Plus One Robotics. My job is to essentially take our technology and essentially figure out where it works and where it doesn't. And so with that, keeping that in mind, we're going to kind of probe our two guests here about how this new technology is essentially going to actually be valuable for the rest of the industry. So to give you a little preview, here's the agenda. We're going to be getting some introductions from our guest. I am going to introduce some of the topics that we're going to discuss, and we're going to do a little bit of a recap of something very special that we did last week, which was an 8-hour live stream and how that pertains to the rest of the industry. And also some announcements on where you'll be able to find Plus One Robotics in the coming days. Okay, so
Sure.
to get started, let's start by introducing our guest. Let's start with Joe. Joe, tell us what it is that you do at Plus One Robotics.
Thanks, Jose. I'm Joe Brandt. I am the sales director here at Plus One. I've been in this role for about a year and a half now, but I have been in the automation industry now for over 10 years in various sales roles, both in the logistics space as well as the manufacturing space, but heavily focused on robotics. Work with our end users. I work with Jose here to validate solutions, particularly here in logistics, and get those implemented. So that's a little background on myself. I'll kick it over to Dan.
Yeah, so I'm Dan Grollman. I am the staff software developer here at Plus One Robotics. I've been here over 7 years now. I do a lot of different things, but right now I lead all of our AI ML development, particularly this exciting new project that we're going to talk about today.
Yeah, so to kind of summarize that, we essentially have both ends of the spectrum. Dan Grollman here actually has a PhD in computer science and AI, and Joe Brandt is not necessarily a PhD, but he's the Dr. Mullah, Dr. Money, if you will, for Plus One Robotics. So I'm really excited to have both these two ends of the spectrum working together and talking together about how this essentially AI, new wave of AI is going to help in the industry. Awesome. So to kind of give you an idea of what it is that today's, internal project is about, it's essentially what we call incremental automation. And you will learn about what is incremental automation, why do we need incremental automation in logistics, and why should warehouse operations opt in for it. And then towards the end of the webinar, we will discuss how incremental automation will increase profit and help your bottom line, and what the road to a maximally autonomous warehouse looks like. Are you guys ready to get started?
Let's get it.
Let's do it.
Awesome. Also, for our guest, a couple notes before we get started. If you have a question, please put it in the chat and we'll address it at the end. And also just be aware that today's presentation will be recorded and we will be sending a follow-up email to everyone with a link to the recording, just in case you missed something or you want to rehear something later on. Awesome. Let's move on to our first question. And I'm going to start with Dan. Dan, before we get into the specifics of this incremental automation, let's just address the room and let's address the elephant in the room and acknowledge that there is a lot of noise right now around AI powered robotics. How would you best describe the gap between long-term vision of fully autonomous warehouses and what we currently have today?
Yeah, there's a lot of really exciting work going on these days. It is a great time to be a roboticist. You see all these great advances coming out of the large models,
Right.
lots of really neat hardware advances coming out of the humanoid space. People are putting together doing really amazing things. But when I look at warehouse logistics, there's still a big performance gap, right? You can get a humanoid robot to do partial induction. We saw a video the other day, a live broadcast of it running for a long time,
Right. It was like
which is
7 day
super cool.
broadcast. Yeah.
Yeah, it was super cool. Still, the untrained human does it better, and a finely tuned system like our Induct One blows out of the water. So there's
Right.
still a performance gap of can you actually do the job that needs to get done at the speed that it needs to get done. So that's one thing. That's closing. That'll close. It's a question of how long it'll take to close. The other big gap I see is in this sort of what gets automated, right? There's this vision of we automate the entire warehouse. That's still a long ways away. Right now we're automating parts of the warehouse. And so there's still this gap of coordination between the various systems in the warehouse to get them all working well together. And that's where our project, internally codenamed Thea, that's where that project comes in.
No, okay. That makes a lot of sense. And I guess whenever you how would you describe incremental automation to our audience who isn't familiar with it?
Yeah, it's the idea that instead of trying to automate the entire warehouse at once, you automate one small part of it. So maybe you start with partial induction, right? And you just automate that. And then you incrementally grow the part of the system that's automated. So if you've got an induction system, maybe now you add a bulk and feed that's smart and adaptable and autonomous. And then maybe
Right.
you add a sorter. And so you grow the footprint of autonomy within your warehouse rather than having to re-automate or rebuild and automate the entire warehouse all at once.
Gotcha. So you're giving layer by layer a bit more control of your warehouse operations.
Yeah, and it really allows you to focus the automation effort on the parts that actually need it, right? So you could automate everything, but maybe this part over here works fine. And maybe you don't have the budget to automate that right now. So you can focus your time, your effort, and your money on automating the part that actually needs it to increase your overall warehouse efficiency.
Right. No, that makes sense. And okay, and let's kind of break it down just a little bit further. You mentioned internally that the or this, incremental automation project is really about expanding that adaptability, and it's not necessarily another RFM or another brain for a single robot, but for
Yeah,
the body as well. Can you unpack what that means in practical warehouse terms?
absolutely. Or at least I'll give it a shot. Uh, the the key thing about this project is that we're looking at variability both in task space. So what is the job you're trying to do, and what are the things you're trying to do it with? So if you think about partial induction, again, that's sort of my favorite application in the warehouse. Are you handling just brown boxes? Are you handling black polys? Are you handling everything that might get shipped, which is a large, ever-changing set of materials? That's task variability. But we're also considering embodiment variability. So are you a single arm induction? Are you a dual arm induction? Are you induction with a conveyor attached to it? Are you induction and the bulk infeeder and the sorter? And so as you add more and more bits and pieces of hardware to the system, the way it works right now is you optimize each one of those individually. You might optimize the induction system, you might optimize the in feed, you might optimize
Right.
the out feed. Thea, the idea is it is a system that takes all of these inputs and treats it as one unified system and actually optimizes not just the individual parts, but the flow between them.
Right. Yeah, I'm assuming this would also expand to, what we consider upstream, downstream of our induction system. So you could add layer by layer a bit more of, maybe you want to focus entirely on the upstream first. Give it
Yeah.
first mostly upstream control up into itself, and then later on, once you feel more comfortable with it, maybe you add downstream. So it gives you
Yeah.
some flexibility as to what you want to automate and give it, control over, right?
Exactly. You identify the bottlenecks that you care about, and then you can target your automation effort there. Maybe your
Gotcha.
in-feed is fine, so you can just skip that, and maybe you need to automate depalletization, right? Maybe
Right.
that's where your bottleneck is now. And so you get to focus your effort and your time and your money on the parts that matter to you.
Right. And I guess just so, because I think it helps me understand, um how would this be an upcharge, or is this going to be the default for, plus one systems going forward? Would someone outside of plus one even notice a change when Thea is running as to before?
Yeah, hopefully you'll see improvements in efficiency and effectiveness, right? Because now, again, even within our induction system, we've got, 2 arms, 5 conveyor belts, and they're optimized individually.
Mhm.
But when you bring a project like this online, they're going to start to learn how to work better together. And you should be able to see more efficiencies, more effectiveness of the same hardware that you already have that only gets better as you add more hardware.
Right. No, that makes sense. Okay, so let me hear from, yeah, like I was just about to bring you in, Joe. What questions or what thoughts come to mind as the money guy in this group?
Yeah, so I guess before my question to Dan, I just wanted to kind of hone in on a finer point here on like what this actually looks like in practical terms. So we talk about incremental automation and kind of adding more layers to your automation stack. When we talk about that, specific to Thea here, we're not talking about automating additional items, going from manual to an automated process individually. We're not talking about necessarily stacking that on top of each other. Um, it's leveraging, the intelligence we have available to us today to optimize how they work together. So right now at Plus One, we use reinforcement learning on the vision side. So we take a 3D image, we identify where a package is, and we allow that robot to go and work. What this does is expand it beyond just the camera. So, for example, you could have a camera and a robot and a conveyor and all these items tied together and leverage that intelligence we have, not just to optimize each one individually, but to understand how they work together and kind of optimize that entire process flow. So, just, way more inputs and outputs than we're used to dealing with today.
Right.
But it's something we are, used to or, well positioned to handle kind of in our more limited scope of vision right now and expanding that into a broader process. Um,
Right.
so it
I,
goes
I
a little
guess
beyond just manual to automated.
right. I guess why is plus one so perfectly positioned right now, Dan, to be the one to start this project? Is it the large number of data that we have, or simply because we just hire the best talent, and if no one can do it, then, if we can't do it, then no one can mentality?
Well, of course, everyone on our team is fantastic. I
Right.
I really do enjoy working working here, working with all the people. Everyone is top notch. I think what sets us apart is we are not purely academics. We're not just working on the next ML thing. We're not working on the next system. We have deep knowledge of the task at hand. And what actually, we're submitting a paper right now to a conference where we're exploring where do these theoretical limits happen? Like, what is preventing us from taking these great advances out of academia and applying them to real practical problems?
Right.
And one of the things that we found is that the requirements of our problems force you to make certain decisions about the architectures you use and how you apply them. And those aren't always the same decisions that are made during the theoretical advances. And so we have this sort of unique insight of what is the thing that actually needs to get done.
Right.
what constraints does that put on the system, and where do we need to work to make the system actually function? And that's what I think really gives us an edge here.
No, that makes sense.
Right. So I guess my question to you, Dan, would be, we're talking about optimizing, individual pieces of equipment independently, kind of as things are done currently. So with this layer by layer approach of how warehouses typically automate versus doing everything all at once, which is at this point kind of a pipe dream, as all tasks are not automatable currently. So how does Thea kind of tie into this structure of automation and kind of explain in practical terms what this would look like on the floor, like maybe starting with like our Induct One package induction system and expanding that over time.
Yeah, so this framework was really designed to be used in just that way, where you are incrementally automating the parts that you care about, rather than trying to redo your whole warehouse all at once. And so the idea is maybe this year you automate just induction. You see here our Induct One induction system. And maybe next year you say, oh, well, we could use a little more throughput on this side over here. And you add that there. And you add automation there. You get a smart sorter or smart infeeder or smart depalletizer, etc. And so really the whole thing is designed to be amenable to this sort of piecemeal automation, which is what we find actually works really well in practice, right? Not many companies can rebuild their entire warehouse to take advantage of the latest technology. So instead, you add it in where you need it, as you need it.
Okay. So what I'm hearing is, someone who's a warehouse operator or systems engineer responsible for the process flow through a warehouse is that we can kind of observe and evaluate this process as a whole rather than just as unified systems that run independently. So, rather than optimizing your induction process here, you can see and predict how that would affect the sorter downstream, how that would impact the bulk feeder upstream, and kind of see how, the right hand affects what the left is doing, if that makes sense.
Right. And then as you bring, I guess, more right hands or more left hands online, they start to work together. Right. So again, it's not just, I'm going to optimize this one bit. It's, yeah, I'm going to automate this. I'm going to optimize it. I'm going to get it better. But now I'm going to optimize these two things together and get even more out of both.
Cool. Yeah, and I love having this video kind of playing in the background because it helps people understand, like as I start to like look at this, how much control we already have individually. So just for everyone's context, there are essentially there are essentially five types or four types of engineers required in the execution that is Induct One. One of them being the coder, the programmer, which is our vision system. One of them being the PLC guy that controls the conveyor logic and timers. Three being the robot programmer. Four being the so something has to tell the system that there are packages there. So we call that object detection. And then five is the HMI and Internet of Things. So currently, each of those systems is, commissioned and executed individually and then kind of put together. And, one of my jobs is to see what happens when all five systems interact with each other. In the future, it's going to be, this layered automation or Thea is going to take control of each one of those aspects one by one and ultimately go from five, engineers for commissioning to just one. Am I understanding that correctly, Dan?
I mean, that sounds great. I think it'll take us a little while to get there. I think initially you're still going to need people who understand all these bits and pieces working together. But eventually, yeah, the dream is you pop the system down, You feed it, and it goes from there. It just takes it away.
Right. And I guess, Joe, so what, when, based on customer conversations that you're already having, what are some of the operational pain points that make this kind of system level intelligence compelling to them?
Yeah, so when you talk with end users managing a warehouse, for example, there are countless individual processes that occur between the loading dock and the shipping dock. The way the packages are processed, sorted, all of that. And working on or optimizing individual systems within that process, oftentimes they describe it as kind of like whack-a-mole. Like you fix one issue, you change one issue, or you change one system, and another one can pop up. Maybe you change how packages are sorted or presented, and it has some, maybe unintended consequence downstream that you then have to deal with. So these issues pop up, and it's hard to foresee. There's just so many variables that happen between all these systems. It's really hard to predict how that can happen. So, whether it's logistics or manufacturing, whatever the process may be, a lot of it can be kind of to some extent, some guess and check. You fix an issue and something else pops up. And you're just trying to find kind of that right mix of what works best in your warehouse. When you think about it this way, when you think of it kind of guess and check, this is where, AI and using that intelligence that we use today is ideal for. So, um, taking those millions and millions and millions of data points that show how one process ties into the next can help predict how altering a system a certain way can affect processes downstream. Um, so it's kind of the unsexy work of warehouse optimization that you kind of have to tinker with these things and see what works. And this is a lot of the grunt work where this, kind of brain of this, Thea type system can can cover a lot of that lift for you.
Right. And I guess a follow-up question to that would be, would you need to have, you know, large scale operations for this to succeed? Like it's like, do you need a whole bunch of data that, or are the only customers that would benefit from this the major 3PL existing 3PLs, or would even a medium sized, a maybe someone that only ships, one kind of product like apparel benefit from a system like this? What do you think?
I think it can be applied very broadly. I would argue probably the fewer amount of systems and variables that you have, the better understanding that Thea would have of how these systems tie together. It might not necessarily be beneficial to where you have a fully manual process with like a box taper or something that's automated, that's very isolated. But
Right.
when you have automated processes that tie together, that's when this can really tie in. And I think the advantage of this is, it's hard to know right now what this will look like commercially, but there's really kind of no feasible limit to how much data we can handle in this. Adding one process in and another, it's just processing more data. It's just, tacking one onto the other. It's not a huge lift from a hardware software perspective. So it can be expanded rather easily at a relatively low or no marginal cost. So it's a system that can kind of grow with your operation, if that makes sense.
Nice. And it works just as well with, even with, because we're starting it at a certain baseline, upon deployment, it's already going to have like, it shouldn't be any worse than what you were already using. It can only improve. Am I understanding that correctly? Like even in a small data sized pool, it will still work just as well.
Yeah, you certainly want a good layer of data to get that baseline. And these warehouses are doing hundreds of thousands of picks a day. So that data collects very quickly, and you can understand the relationship of how these work together. And our system can suggest or alter itself some current processes or some existing processes to make it more efficient. But one thing that's kind of our philosophy of the company, and we'll get into this later, is having that human in the loop. So we always push and reinforce with the good outcomes, better throughput, better quality, things like that. but we always keep that human in the loop. We can always revert to past processes if needed. So there's nothing really forced by this system. So, anything beneficial you can keep, anything that's not beneficial for whatever reason, you can just revert
Gets
back to
filtered
the
out.
order.
Right.
Yeah,
Gotcha.
exactly.
No, that makes sense. And I guess one last follow-up before we move on to the next one, and this is more for Dan. If the average user is already accustomed to, MLMs, right, for in their workflow, how would you maybe describe Thea to the average warehouse operator? Is it something that they would interact with, or is this something more completely in the back end?
Yeah, that's a great question. I think on the whole, it should be pretty invisible, right? It's just you put your new hardware in, it's got software running on it, it's going to adapt over time. You may need to tell it if things are changing. So one of the big things we're looking at is when your input changes, if you're getting new styles of packages or different distribution, the system needs to adapt to that.
Right.
Joe was talking about tweaking, right? You could have engineers out there right now tweaking all the systems you have to really optimize them to work with the packages you see. But when those packages change, you need to redo all that.
Right. Seasons change, marketing campaigns change.
So what Thea does is
Taylor Swift album drops tomorrow.
Exactly. All of a sudden her face is on everywhere. Right. What Thea does is it automates that tweaking. And so there's some advantage to being able to say, hey, I think things have changed. Go adapt to it. But I think if you leave the system to itself, it'll also eventually discover the fact that things have changed.
Gotcha. So it should be pretty touchless.
It's pretty touchless, but if you know things, it's always great to share that with the system.
Gotcha. So could we theoretically still give it prompts the same way we currently interact with AI, where it's like, maybe I know something will happen. Maybe the system hasn't seen it yet, but I got feedback from one of my largest customers that they're done doing poly bags, so everything's going to be paper bags and boxes, cardboard boxes. Could we proactively prompt, Thea the same way we already prompt current AI MLMs?
That is an interesting idea. So what we're working on right now doesn't have language capabilities. So there's no place to put that linguistic prompt of saying like, hey, this is happening. But there is a place to put visual prompts. So you could say, these are pictures of the things I expect to be able to handle.
Right.
Adjust to them. And we could pretty reasonably include the linguistic stuff as well. It's just not something we're working on right now.
Makes sense.
So, Dan, I wanted to ask, and if we could bring up that video kind of as a reference here, I want to try to kind of give a practical example of what this could look like. So, just for example, this is our Induct 1 system that's running. We have the live stream on YouTube. This ran for 8 hours unassisted. But if we were to tie in Thea into this, and I guess to set the stage, right now, Plus One, we control the vision system that sees these bulk packages, gives a pick point for what we identify as a single package, and we place. And we optimize for that. We optimize for the vision, allow the robot to pick and place single packages individually. When we talk about expanding this scope with Thea, what could that look like, just as an example or two in practical terms within this process?
Yeah, so one thing you can see in this video is the conveyors and the arms, and actually the two different arms, move completely independently. Right? Each one's sort of a system unto itself. We're going to get an advertisement here, I see. Where the conveyor brings stuff in, stops, the arm picks it up, puts it down, and then the conveyor goes forward. Right? And that's because when we develop the system, it's easier for us to sort of separate these things out and optimize them independently. We optimize the conveyor, we optimize the arm. I think when you see something like Thea get applied to this process, we're going to see the conveyor and the arm working more synergistically together. So one way that might look is maybe the conveyor moves slowly all the time, just to get that little extra bit of throughput through. And the arms adjust as the conveyors move. Maybe the conveyor works with the arm to position the next target object in the place that it's easiest for the arm to reach. Right? These are things that are not beyond the capability of human developers, but they are a lot of work to get right. And we're hoping that Thea, from learning and exploring and adapting over time, will discover these sort of synergies by itself and really optimize the whole thing holistically.
Right, Dan, something that me and you have kind of said when talking about this kind of technology is that when we design systems, we as in Plus One, yes, but also we as in humans, we program and design these robots to work with a human in a human bias way or in a human's the way I would do it as a human. Something that you told me is really the big potential of AI controlling more of these layers is that they might find that maybe leaning something to the left right before placing it works best and works fastest versus a human just only thinks up and down, or the human thinks transferring like this, putting a package in the middle is the best way to go about it. But as over time, as the AI starts to learn, is given the freedom to experiment, it will find that it can always have that place conveyor running, and it'll just kind of toss them in their juggling style. Right? We don't really know what it's gonna look like, but that's the exciting part. It's the fact that it will get away from a human centric design.
Exactly.
Yeah.
We have our own biases of how we think about things, of how we perceive the world, of how we act in the world. There's no reason to force robots to comply with our perceptions of how things should be. My go-to example is always like, I can't see depth at the millimeter resolution. I'm just not that good at that. I can see depth, of course, but I can't see that's 1 millimeter and that's 2 millimeters. There are sensors we can give to our robots that can perceive these differences. You think about hyperspectral cameras, you think about new contact, torque, and force sensing capabilities. These things are all superhuman. So why should we limit the robots to behaving the way that we think makes sense when they have these other capabilities that they could use?
Right. I love it. I love it.
Yep. And I think just to kind of circle back on the point made earlier, like when you were talking about the conveyor, maybe there's a better way to handle this. You can see sometimes where this downstream robot can be starved waiting for packages. And as a controls engineer thinking about programming this conveyor, probably the simplest way to do it and the way it looks like it's done now is when the photo eye is blocked down there at that conveyor, or when it's not blocked, you convey more packages until it's blocked. That's a simple enough thing to program. When we talk about kind of a steady, more even flow, like maybe that'll work, maybe it won't. What speed do you run it at? How quickly can we account for it? How quickly do you accelerate it? These are things that are hard to know up front and takes a lot of, like we said, guess and check and guess and check and guess and check. And it's just really tedious and not practical for us to do things that Thea can have insights into that we don't even think of. So this is just one example, but a conveyor is just one piece of this system. There's the upstream, there's the downstream, and that's where you can kind of expand this thing and tie in and really see how they work together beyond what we as humans are capable of observing.
And particularly when those sort of strange scenarios or edge cases happen 1 in a million times, right? It's a question of how much effort do you as a human want to put in to optimizing for that 1 in a million case. When we do 1 million picks a day, so we see each of those every day, Thea across our whole network can learn and optimize against those edge cases.
Right. No, that makes sense. Cool. I guess we did touch on this a little bit earlier, Dan, but let's kind of bring it back to, the core, one of the core pillars of Plus One Robotics, right? Our logo or slogan is robots work, people rule. How is Plus One, as these systems become more autonomous, how is Plus One, or why do you believe that human oversight should still matter?
So the quip I like is that humans are part of the problem, and therefore humans need to be part of the solution. And what I mean by that is we're always changing. We're always changing the system. We're changing what we feed to the system. We're changing the demands on the system. We're changing the requirements of the system, right? And if none of that happened, we probably wouldn't need humans in the loop because what we're dealing with is a constant. But the fact that it changes in ways that system designers and system developers may not have anticipated, that's why we need the humans in the loop to be able to solve the problems that we did not previously conceive of. So you look at what we have right now, right? So Yonder is our human in the loop system for our induction solution, our induction and depalletization solutions. And we see things every day that are outside of anything we would have suspected. Packages burst open and spill their interiors all over the conveyor belts. People leave tools, or my favorite is someone left a sneaker once on a conveyor belt. It comes into the cell. What do you do in that situation? So you
Right.
need a human who has the human knowledge of like, this is weird. This shouldn't be the case. We shouldn't do our normal thing. We should do something else. You need the human there to be able to provide that input.
Right. The robot would see a random shoe and just look at it as a package without wrapping.
Yeah,
And
maybe it inducts it. In which case, do you want that going down your downstream?
right.
Possibly not.
Right.
Right? Or someone spills a package. We saw one box of coffee burst open. There's coffee grounds all over the conveyor.
Right.
Do you want the system trying to pick up the broken box and try to put it on the outbound and you get coffee all over your outbound as well?
Right.
No, you need humans to be able to provide the human level knowledge of like, this isn't what's supposed to be happening.
Right.
Let me do something else.
So whenever something like one of these edge case scenarios happens, such as, coffee bags, maybe because it's the largest thing that gets shipped that month, it just happens over and over and over again. And these systems are meant to run kind of in the background and adaptive to learning. What keeps a system like this from creating bad habits the same way human does when they're constantly, exposed to a harsh environment?
Yeah, so we do rely on our humans in the loop being good at what they do, right? This is skilled labor. This is figuring out what should the system be doing in response to this scenario. And once we see that a couple of times, we can learn it. And then the system can hopefully do the appropriate response in that scenario the next time, right? But there's also why we have human oversight and we have rollbacks and we have all of this infrastructure in place for if things do go wrong. If the system learns a bad habit, we roll it back, right? We can say, oh, we learned that maybe our process has changed. Maybe what we thought was the right thing to do was no longer the right thing to do. Well, let's remove that data. Let's roll back to before we learn that behavior and learn something else instead.
Right.
And
No,
that's
that
all the
makes
stuff
sense.
that goes on around the process.
Yeah, because I'm sure when Joe's working with his customers, they also would like to have a certain, safe feeling that implementing the latest tech isn't going to also mean implementing the latest errors, right? Finding errors that no one else has ever seen because you're so at the edge of technology.
Yeah, I think this is provide a good example with the sneakers of why humans are so critical in the reinforcement learning space. We know better than machines do at this point what what we're reinforcing. If we say, for example, with induction that the goal is to induct items successfully, it might pick up that sneaker and place it on the belt, and it'll say, "Yay, I inducted an item. Good job. I learned from that, and next time I see a sneaker, I'm going to keep inducting it." I heard an example before of a box of birthday cards that was opened, and we would go in, we'd pick one card at a time and place it. We were just unstacking cards from this box, and you see it, and we're inducting all these items successfully. Let's go. This is good.
Right.
Keep learning from that. So it takes the human stepping in where we can, see our system, see what it's inducting and say, whoa, this isn't right. This is wrong. And add that reinforcement in rather than allowing it to run completely unsupervised. So
Right.
these are things machines they're smart, but they're not smart enough to know these minute details.
Right.
And as long as there's some variability and some change and some unexpectedness, we're going to still have this problem. And we believe that for the foreseeable future, there's always going to be some unexpectedness. And we need humans to deal with that.
Speaking of foreseeable future, Dan, when people hear AI and robotics, they often imagine some massive leap all at once, right? All happening at once. But it sounds like your view is that the future arrives in layers. What does the next few years realistically look like for warehouse automation and operators?
Yeah. So there's this dream of, if not fully lights out, nearly light out, maximally autonomous warehouse, right? And I think that's a really cool goal. I think it's a couple of years away. And so the question is, what do you do between now and then? And so you can either wait, right? You can wait for all the technology to be developed and then build your perfect warehouse. But I think you want to be able to reap the benefits of the technology now and not wait for the end goal. And so this layering idea of
Right.
let's let's automate what we can and then automate some more and then some more on top of that and more on top of that. That bridges us from here where we have, we have smart induction, we have smart decal, we have all these various things. It bridges us from here to there, which is a fully integrated, maximally autonomous warehouse.
Nice. Awesome. I loved having both of you guys talking about, additive automation, Project Thea, codename Thea. We will be doing a hard launch in a few weeks here. Um, thank you so much to both of you, Joe and Dan. Lisa, can you bring up our slide deck about where to find us? Okay. Plus One on the road. So here's where you can find us in these next few expos. Eric is in Boston this week for the Robotics Summit and Expo. I'm sure there will be some YouTube clips or some TikTok clips coming out of that expo. So be sure to look for those on our LinkedIn. And we'll also have a team at Automate next month as well, from June 22nd through the 25th in Chicago, my favorite city of all time. Let's go. And thank you so much to all of the guests that joined us. I don't believe we have any questions. Do we actually? I do see a Q&A. Let's see. Oh, Brenda. Cool. So,
Oh, that's from Mark.
Mark Anthony,
Yeah.
can you explain more about the guidelines between what should be automated and what does not need to be automated? Perhaps at the moment. Yeah, let's just use today. Let's assume Thea is rolled out today. What are the guidelines between what should and should not be automated?
So I think we can think about this in two parts, both kind of pre-Thea and post-Thea. Right now it's kind of the way it has always been. I think when you look at something that you'd like to automate, you need it to either increase your quality, increase your throughput, or lower your cost, or some combination of the three. I think in general, when you look at the technicals of what you're doing, it should be some process that is, somewhat repeatable to an extent. So, if you look like induction, at something like induction, it's something where the packages are generally within reach of a single person. So therefore, within reach, the pick and place is within reach of a single robot. We have the technology, our vision system, to be able to take a picture of that scene and identify where a package is and where it needs to be placed. So something like that a human can do repeatably, and I don't like to use the word mindlessly, but somewhat without a ton of effort or brain power. Those are the things you target first. And of course, you want to be able to keep up with the rate, which we can, improve quality to an extent, and your ROI will be there in replacing a manual operation. We look at each process by case basis. Some things, even when they're repeatable, if you have extremely high variability, for example, I mentioned like a automatics box taper earlier. If you just have tens or hundreds of sizes of boxes, that can be very challenging, and just be very costly and not have the payback you're looking for. So it's all case by case basis. These are the types of things I look at with customers and try to determine sooner rather than later if this makes sense, or if that's something you put off later. When we're talking about the post-Thea world, we're really talking about which processes do you want to evaluate that are tied together. So ideally, it's something where one automated process feeds another process, and then you can start evaluating both of those together within Thea. So take your inputs and outputs from one process and the other, and then Thea can start crunching that data and seeing how they tie together and how they can be cross-optimized to work together as, one whole process, if that makes sense. So you'll generally want them to kind of be close together rather than, not that it wouldn't work, but how does your shipping dock or how does your inbound dock affect your shipping dock? Because those are so far apart and there's so many variables in between.
Yeah.
So it's hard to make that correlation, if that makes sense.
Yeah, I like the guide, when you say guidelines, I immediately think of kind of like rules. And for the most part, like just said, it's case by case basis. But one of my favorite ways to think about what can be automated is if you already track metrics for it. Because that usually means it has sensors or it has some sort of like input and output that you can work around and add automation to it. So if you already have metrics for something, more than likely it can be automated. You're not tracking how many times you move, orange cones in your building, not really something you want to automate. You are tracking, how many large boxes get into this one sorter, or you are tracking how many times a reject package has to be manually sorted, right? So if you have tracking metrics for it, it's a good contender to be added to this additive automation.
Yeah. You can't justify an increase in quality or rate or anything unless you're tracking what you're doing already.
Exactly. Yeah. Yeah. Big. That's a nice rule to go by if you're already tracking it. Awesome. Guys, thank you so much. This is actually a very momentous moment for us. This wraps up season 2 of our Get a Grip webinar series. We are working on topics and speakers for season 3, and we'll be sharing that soon. If you have any ideas for a topic or even a speaker, right? Maybe you have a LinkedIn influencer, you've always wanted to get his opinion on some of this technology, put it in the comments, put it in our YouTube channels, or email Lisa with that information. If someone at your company would like to, learn more, send them our ways, because sometimes the best way to gauge how our messaging is working is if people from that have, are not too familiar with us can also understand the technology we're deploying. Joe, Dan, is there any closing remarks that you guys want to share?
All I'll say is it's been exciting to talk about this project, and I know it's hard to talk in great detail about what a upcoming product will look like before development is fully complete. But definitely stay tuned. There's more to come, and certainly feel free to reach out to all or any of us as things develop in the future, or if you have any questions that we might be able to help with.
Right. And Dan, your turn. Let people know where they can find some of your work too. People love hearing from doctors.
I think most of my relevant work is actually on our website. We have a whole section on research articles and blogs. We write there and share what we do extensively. I'm echoing what Joe said. It's a very exciting time to be in automation and robotics and machine learning. I'm very interested to see how the next 5-10 years shape up.
Awesome. Thank you, guys. That is the end of the webinar. If you have any question following today's webinar or want to discuss more about Plus One Robotics, you can find our guest on LinkedIn or reach out to me or Lisa and we can connect with you. Thank you to my guest and everyone that attended. Enjoy the summer and we'll be back soon.